What happens when we have actually a billion users actively transmitting money across border? How are we going to do this? And the problem is that with traditional blockchain designs, you can improve the capabilities of the system to a point, but there's always a limit. When you reach that limit, what do?
What are these design elements that you went for to solve the issue of scalability and latency?
We want to give users reserved block space to interact with their applications on their own blockchains or on specific blockchains that we can spin very easily for them. We're trying to avoid making users compete for the same resource. And so in blockchain, what's missing is this quality of service. It works until suddenly there's a rush hour, you start seeing delays, you start seeing higher fees. So we don't want that. What we want for the world is to be able to use reliable systems, and they happen to be decentralized in some cases. This is really the magic of blockchain that we all love.
Hey, Sohail here. Thanks for tuning in. Real quick before we begin, if you enjoyed this episode, if you learned something, please consider to follow or subscribe or share this episode. That helps us out a lot. It helps us to reach more people and to spread quality education across the space about crypto and Web3. Also, if you're part of a crypto project or represent one and you would like to come on the show or do sponsoring, please get in touch with us. And lastly, everything we talk about today is for educational purposes and no financial advice. Enjoy the show. Mathieu, welcome to the TEACHMEDEFI podcast.
Hello, hi, thanks for having me.
Lovely to have you here. There's lots to chat about. I mean, I looked at your CV and it says you have a PhD in cryptographic protocols. You were previously a research engineer at Meta's Novi division. Is that correct? Novi?
Yes, that's right. Yeah, that was the latest name. Mm-hmm.
Okay. So obviously you were involved in a lot of things there. I think, with the whole Libra Diem stablecoin project and all. So perhaps we start with that. Can you give me like an idea of your background and your journey into this whole crypto mess?
Yeah. So as you said, basically my story is like I'm French, so studied in France, did a PhD in cryptographic protocols back then. Started working in the industry. I mean, and then moved to California to work at Facebook back then. So I had really like a good time there, working as a software infrastructure engineer in many different teams. One of them was a machine learning team doing like super scalable services. So I learned a lot from there, and then I got, because I had this security background, I got this opportunity to join the early blockchain project of Facebook. So to join a project as one of the early engineers, and that's how I got into crypto, basically. To answer your questions, I knew a bit about Bitcoin before. I thought that was, as a protocol engineer, I thought the protocol was super interesting, but I was not using it in particular ways. But then that's really started. I got into crypto really with the blockchain project of Facebook.
Amazing. I think some people will be curious, including me, like, how did you end up at Facebook? How did that happen? You were in France, you were studying, you finished your PhD, and then how do you end up in the US?
Yeah. Okay. So that's the whole story. But yeah, basically, I was in a French startup. I started my career more like a researcher, a consultant, like an expert in security. And but then I wanted to also, at some point, I wanted to work in a startup. That was really attracted by the idea, and so I did that for 2 years, if I remember correctly. And there was a point where I was traveling in California for work. In fact, I was like more like a manager in the startup and trying to do a bit of business development. And I kind of lost faith in the startup. I had a few friends at Facebook back then. We were like, it was a difficult project. They were very, very interesting, but kind of difficult on the commercial side. So I had friends at Facebook, and I was telling them, hey, you know what? I think I might just I might just switch. And they're like, oh, why don't you interview at Facebook? And that's how it started, basically. Also, I had such a great time in California. So I don't live in California anymore, but I I still really like the country, and yeah, it's really it was really from Paris. Suddenly, like, if you like vacations, the weather is so beautiful,
Yeah.
and the jobs are super interesting, obviously.
Yeah, yeah, I feel
Mhm.
that, especially the weather. I mean, I live in Germany. It gets dark and gray and rainy and cold. So, yeah. And those friends of yours, were they also from France, and then they went to Facebook, or or were they already in the US before and then at Facebook?
Yeah, they were already at Facebook. Yeah.
Okay, okay. Well, awesome. So you wanted to try out the startup thing. You did. Then you went to Facebook, and now you're kind of back to startups. So you started Linera, right? You're a co-founder of Linera.
Yeah, I'm definitely, the whole time I was at Facebook. I mean, I was always, I was eager to learn more about, like, how you build the scalable systems and the tech. I really wanted to initially really wanted to become like just a better engineer, essentially, like, and my idea was, okay, because I want to go back to work in a startup after that, and I want to make it happen. So the blockchain project was obviously super interesting. I learned a lot from there, and also, yeah, it was lots of so talented, so many talented people there.
Actually, there's been a lot of projects that came out of this division at Facebook, right? So like one of them is you guys, but there's other ones too. I mean, what is it? Aptos, I think, right? Is it
Aptos,
Say
Sui,
as
of
well?
course, yes.
Sui,
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 yes,
Sui.
yeah. Mhm.
Did you work with all those guys together? Do you know them, or was it such a big division that these are separate people that you
Oh, no,
don't
no,
really?
I know them very well. Yes, of course. Yeah,
Hmm.
the now CEO of Aptos was, like, really, I worked very closely with him at the very beginning, like on the blockchain protocol of Libra, which was renamed DM, right? And then the research, my colleagues, yeah, my co-authors on the research that ended up being Linera, also are at Sui now. Yeah, of course.
All right.
Mhm.
That's exciting, funny. And what is Linera? Like, what are you guys working on? Why do we need another layer one, so to say?
So the story goes, like, we were working on the blockchain project Facebook, on the consensus protocol, and things were doing well. So with some of my colleagues, we started having a bit of time to do research. And one problem that started kind of obsessing us was, what happens when we have actually a billion users or millions of users actually using what we're building, and actively transmitting money across cross border. How are we going to do this? And the problem is that with the traditional blockchain designs, such as the one we were building there at the time, with traditional blockchain designs, you can go, you can improve the throughput, you can improve the capabilities of the system to a point, but there's always a limit. So perhaps um, 100,000 transactions per second, or 200,000 transactions per second, or even more, maybe. But there's always a limit. And the problem is, like, when you reach that limit, what do you do? When you work on a traditional, in the big tech industry, when you work on the cloud, you don't have this problem. You don't have a limit. So you know that if you have suddenly many more active users, you will always be able to increase the number of machines in your system. And so coming from big tech industry, um, the we were, like, always a little bit uneasy with the blockchain technology, and a bit in fear, like what happens when we have so many users that we exceed the capacity of the system. And so we started working on a low latency decentralized payment system, and that went very well. We published. We're pretty happy. The protocol was very simple, very nice, but it was only doing payments. And so essentially, Linera is a generalization of this protocol that was called FastPay, adding smart contracts, and turning it into a full layer one infrastructure with a twist, like with this initial like design that is very different.
Okay, interesting. And how what are these interesting design elements that you went for to solve like the issue of scalability and latency?
Yeah, so basically what we're saying is like the what we're saying is we want to give users reserved block space. So we want users to be able to run to interact with their applications on their own blockchains or on specific blockchains that we can spin very easily for them. So it's a massively parallel system. We're trying to avoid making users compete for the same resource. When you and that's something that is also very very much inspired by cloud computing. When you are on your car using Google Maps, and maybe you're in traffic jam, and everybody around you is using Google Maps, and it doesn't matter. It just works. Like the system has been designed. They know how to add machines when needed. And so what we want is this kind of and people are used to systems to work just work, right? And so in blockchain, what we're thinking is that what's missing is like this quality of service, like that people have been used to. When they use blockchain, sometimes they feel like it works until suddenly it's a rush hour. There's maybe an FTR drop at the same time, and suddenly you start seeing delays. You start seeing higher fees, and yeah, and I think in modern times, people at least it just reminds everybody, oh yeah, this is using blockchain, that's why it's slow. So we don't want that. It's like really what we want for the world is to be able to use reliable systems, and they happen to be decentralized in some cases, which gives us this amazing ability to manage assets on the internet, which is really the magic of blockchain, right? Turning this global network into a financial system, um, without anything else. Basically, just pen and paper. You invent the protocols. You do the maths. You program, and suddenly you create trust. You create a financial system. I think this is really the magic of blockchain that we all love. So so with Linera, we really working on a system that will scale out and uh, and be able to let developers create this new generation of applications that scale, that can really create this a perfect user experience for users. Um, and then for that, so we invented a brand new protocol. And in fact, so the core concept, which I like to call microchain, and is really what helps us, give every user their own tiny chain they can talk to. So we call it like a user chain or a personal chain. There's an analogy I like, which is personal chains. Basically, it's like when personal computers happened. This is really what started the success of computer of personal computers, and the success of just computer science, basically for users. And so before that, there were like data centers, there were mainframes, and as a user, you didn't have access to the mainframes. You had to use a terminal, and it was pretty expensive. But then, so when you start giving a computer to everybody and they have it on their desk, then now they can use it for their personal tasks, and they don't have to rely on. They can do that. They know it's going to work, and so the analogy is about is clearly is, and then of course after that it became mobile. So we kind of following the same trend that went from mainframe to personal computers to mobile. We on but for blockchain. So we started like single chains that are kind of slow, and they're supposed to handle the traffic for every user. And then what we're saying is like, no, you actually need to give users their personal chains so that they can, at least part of the computation, part of the traffic will be handled by those personal chains. But of course, it's also more like an abstraction still, because the personal chains, we still want them to be very secure. So it's not like you have your own chain and it's isolated. It's an abstraction, obviously. It's still very much validated by the network and ensuring all the application variants are there.
Interesting. Yeah. Okay. How is this like? How is this different from some of the concepts that exist? Like, for example, sharding. How is this different from some other scaling models we've seen on some chains? Like, for example, like Cosmos and having the app chains, or ETH rollups, Polkadot and Parachains with their shared security model and their sharded ecosystem. What are some of the differences here, just to understand?
Yeah, so blockchain sharding has been around for some time. This idea that you want to use several chains instead of one, and get the benefits of it would be that you have the scaling factor. Essentially, what you hope is that if you use 10 chains in the one, then you have 10 more throughput, 10 more transactions. You can handle 10 times more transactions per second. Now, the thing is that in traditional systems, in traditional designs, there was this idea you want your nodes to be small, the validators to be small, so you want everybody to be able to be part of the network and validate blocks. That was, that's coming from Bitcoin, from Ethereum. It's a certain notion of decentralization where you really want small nodes, and so as a result, when you create 10 chains, they tend to have different sets of nodes, right? So you have one chain with one set of nodes, and like, oh, I need another chain. So you need to find another set of validators, because each validator, you try to keep them small, right? And that's one way to do it. What we're saying is just that in these frameworks, typically you creating a new chain is a lot of work. You need to find new validators, because basically every chain is kind of an entirely new system. And then the communication between the chains can be relatively complex, notably in terms of security. If the chains have different sets of validators, why should they trust each other? How do I know, like, if a chain tells me, hey, here's, send us some money, should I do that? Do I trust and so some, of course, there are some answers to that, but it tends to make systems way more complicated. And at the end, you don't really get this multiplying factor. And in fact, at some point, adding more chains doesn't really make things faster. So what we're seeing in traditional blockchain sharding system is that they have maybe 20, maybe 50 chains, but they don't have millions of them, or thousands of them even. In Linera, what we're saying is, like, we want to be a real-time processing system. We want things to be instant, like as fast as possible. And so from the beginning of the project, we thought, okay, we want to be real time. We're going to be clear about the fact that we're using large validators. The world is ready. It's we know, like, there are already data centers everywhere in the blockchain industry. It's not a taboo anymore. And so we're going to create a system that's really using data centers, using like strong hardware, because and at the end, users are going to benefit and see the performance and see the difference. So what we said is we're going to have potentially millions of parallel chains, and we're going to run them in one set of validators. So each of our validator is going to be validating all the chains in our system. So our chains are not sovereign in any way. Those are what we call microchain. They are essentially just carrying computation. They are like supporting computation, threads of execution that help us scale out, and they are like parts of this programming model that we're developing. But for the rest, in terms of security, in terms of sovereignty, we're building one blockchain. So textbook proof of stake, and that simplifies things a lot.
Okay, so it would be rather like a small set of validators with strong hardware. Did I get this correctly? Like similar to Solana in a way from the approach?
Yeah, you could say that. And down the road, we could even ask our validators to be elastic. So when needed, they will be required to add some work or some physical machines. And so in a way, yes, I think Solana started the trend, and by now, like I think people are thinks it's pretty normal to do that for modern blockchains. And but in a way, Solana and some of the chains out there, they're still using a relatively classic design. There are some innovations on the consensus side, and obviously they did some work to achieve a very impressive throughput. Like I said, like potentially hundreds of thousands of transactions per second. However, there's still a limit. And what we're saying is like if you're going to use large validators and they are elastic, and you ask them to scale horizontally, well, we would expect the whole system to scale horizontally. But for that, you have to design a new kind of protocol, and that's what we're doing.
Interesting. How do you think about centralization in this context? Like, you know, the usual trade-off between what do you call it, the trifecta, right? In crypto,
The blockchain trilemma.
the blockchain trilemma, correctly.
So in a way, we are walking around it. We're not saying that this thing was a mistake and doesn't exist. We're working around it. But I guess what we're questioning is the notion of decentralization. For instance, if you have we still have like right now in Testnet we have 25 validators. We're going to end up having perhaps like between 50 and 100 validators. So the Nakamoto coefficient, so that's the number of validators, of malicious validators it takes to hurt your system, is still going to be more than the number of mining pools in Bitcoin. So it's not because you have thousands of nodes in your protocol that this coefficient is high. You need to look at the details. Perhaps there are like 10 nodes in the middle that are very, very important, and taking them out would damage the system. And so it really depends how you define decentralization. If you define it in terms of this network can never be halted even by a government putting millions on the table and able to attack like hundreds of machines. They can only slow down the thing temporarily and it will recover. That's kind of the Bitcoin security. And that is definitely a very, very high level, a very high bar for resilience and censorship resistance. And you pay the price when you use Bitcoin because proof of work is actually really expensive. It's a massive amount of electricity and computation that is being used to maintain this extremely high level of security and resilience. But if you are looking into, you have a system that has no reason to be outlawed, and what you want is simply a really high resilience coefficient number, Nakamoto coefficient number. So you don't want validators to be able to collude and hurt the system, right? So so you can design a system where if you have 100 validators like that are with evenly distributed stakes, it's very unlikely that they would suddenly a quorum, like a 2/3 of them would coordinate and agree to attack the system, and it would be you. And of course, you're going to prevent that by creating incentives, economic incentives that make that kind of like really hurtful for them to do that. So they would be caught. They would lose a lot of stakes. They would be slashed. They would lose a lot of money. So you design a system with the correct incentives, and that reasoning. And my point is basically is that you can do that, and the size of the validators is not really part of the formula when you design your system for this kind of economic security. And so why not using large validators?
Right, gotcha. And in terms of the microchains, I think if I understood correctly, each microchain is sort of controlled by the owner. Like, so just trying to understand. So, for example, the transactions are gathered and blocks are proposed by one party, is the way I understand it. Then, instead of like a decentralized set of sequencers, is there like potential centralization risk here? Is there like what if one owner becomes inactive or malicious? Could that hinder like the chain's functionality, that sort of thing?
The design of Linera is we want to be able to spin a chain for every particular task. So to store the assets of one user, or perhaps the temporary interactions between different users. And then we also have chains that are public, and they should keep going no matter what. And so for the third category, you would like to know that the blocks are being produced by a committee, perhaps some guardians, or even maybe the validators of Linera themselves. And that's kind of the classical setup. And but what we're seeing in Linera is that for the other types of chains, the ones that are used for holding the assets of a single user, or perhaps a temporary interaction between two users, this we can do much better. We can do something that is more cost effective by simply delegating the block productions to those users that have an interest in producing blocks in that particular chain. Um, and so if I have a chain and I'm the one storing the assets there, you're going to be the only one. So if I have a chain and it's my own chain, I'm storing the assets there, I'm the only one producing blocks in that chain. That the chain is configured and nobody else can propose blocks, and that helps us simplify the system a lot. You can in particular the consensus protocol and the way the blocks are validated suddenly, because the system knows this, the blocks can only come from one person. We can remove parts of the blockchain protocol, makes that much simpler, much more cost efficient. So technically you don't need a leader election. In some cases, you can even use something that's called reliable broadcast, which is not even doesn't even register as a consensus protocol in the hierarchy of protocols in the theory, in the books. So you essentially have this like super low latency, because you remove pieces of the protocol that would require a more lengthy dialogue between the client and the user, that is, and the validators. So that's one of the innovation, actually. So we call it block delegation. So delegation of block production is one of the innovation of Linera. We are to my best of my knowledge, we're the only protocol proposing that. So not only we have parallel chains with shared security, but we also delegating block production for some of the chains to individual users or small groups of users. And that's really helping us scale out, because now scale out the number of chains, like really multiply the number of chains. And now you can have millions of chains in the system. If some of them are not active, they don't cost us anything. So they're going to sleep in storage. It's a little bit like a user account in a way. If you don't use your Twitter account, then the state of this Twitter account is not going to be loaded in memory anywhere. It's going to just sleep in storage, waiting for you to do something with it again. And that's really important for us, because like I said, we're going to create chains. We're going to create lots of chains, right? Every time there's a new user, they want to do maybe they want to play a game of chess with someone. We can create a chain for that. Macro auction, we create a chain. Temporary workload, maybe coming from our partners, from other layer ones, we would create a temporary chain for that. So we really want to make chains. The chains that are not used, we really want them to be cheap. In fact, and so the way you do that is by creating only creating blocks when you need, and the person that knows when you need the blocks would be the owner of the chain, or those categories of chain. But yeah, now this being said, it's true to your point that if a chain belongs to a particular user, it's not wise for me to move my assets over there unless I want to transfer them to the user. But if I want just to store my own assets, it's better to store it in my own chain because that's where I know how to produce blocks. If I store them on the neighbor's chain, then it's a little bit like I am taking my safe and putting it in the house of my neighbor. And okay, he cannot open my safe, but I need to knock at their door every time I want to get my access my safe. So it's not the best decision. Yeah. So you got a point. Yeah, for sure. You when you move assets around in Linera, you need to know who's owning, like who's producing blocks in the target chains.
Right. Okay. Interesting. And not every transaction is put like on some sort of main chain. Is that how I understand it? Like it happens sort of on like these sides on your own chain, but eventually, do you have to put like a record of the account balance and stuff of this user on some joint state?
Yeah, so this is so in the world of blockchain sharding, people have proposed the idea that you could have local chains, and then you would settle, you would maybe aggregate a little bit like the financial system. You would have like small banks, and then you have a central bank. So there's this notion that perhaps you need to settle again the transactions on a larger chain. And quite frankly, it starts looking like layer 2s and layer 1s when you start doing that, right? So you have the intermediate levels of finality and then the true finality at the end. And so the nice thing about Linera is we don't do that. And that's one of the benefits of having one set of validators for all the chains. Each chain, although the block production may be configured differently, every chain is validated in the same way. So they have the same level of security and the same level of finality. So there's nothing to gain actually by resettling things inside Linera. They're already settled the first time you get a block in one of the chains.
Okay, gotcha. And you guys are in testnet phase at the moment, or I think it's called Babbage. Do I say it right?
Yes. So yeah.
So what's going on? How is it going? What's the traction? What's next?
Yeah, so we're happy we launched our first testnet. So we had a devnet before for a while. We launched our first testnet this year, and we just launched the second iteration. So with more features, in particular, the one we're very proud of is our first official web SDK, like a web client framework, which is, I call it an SDK, but it's actually much more than an SDK because it contains a full client for the protocol, so including a VM and including like just the whole Linera client, the block production and everything. And so for the first time, we with this new testnet, we were able to run the full a full demo of an application that is hosted on our testnet and also running in the browser for users. So yeah, check it out. We call it the fungible demo. It's a payment system, and you basically you can transfer those demo tokens, those test tokens, and then the page in the browser has open connection with the validators. So now, when somebody transmits money to you, you will be notified. You will download the corresponding blocks, and you will essentially execute them. And then we can show a balance that is updated. And what's interesting in this setup, which is very unique to Linera, what's interesting in this setup is that the data that are displayed in the user interface, they are the results of local computations using a local virtual machine. Meaning that we're not relying on a trust party, on a third party for the data that we're displaying on the UI. And that's really one of the problems that we're solving with Microchains also, is that in normal systems where you have a high TPS chain, you can have this high throughput, maybe quick finality time, but when other users, the time it takes for other users to see the result of your transaction may be high. And not only that, they they don't have access to those data directly. They have to ask an RPC provider like Alchemy. They have to ask, okay, what I was told there's something happened on the chain. What is the new data? Can you help me out understand? And right now it's more often than not there's no authentication of the data. So it's kind of a missing link basically in the blockchain design, where people tend to just trust RPC providers because it's more convenient. And frankly, the alternative solutions until now they were a bit slow or expensive or cumbersome to use. And so at the end of the day, there's this kind of missing link. So anyway, so long story short, we launched a testnet. We now have the first time we have a framework on the client side that allows us to do those super secure reactive Web3 applications. We're super proud of it.
Amazing. Sounds like a lovely user experience will come from that as well. And what's been the feedback from like developers building?
Yeah, great. And so we showed that to our community. We've immediately, told them, hey, why don't you create games? Like we'd love to see you use this new framework. So we have a bunch of games, on-chain games that are using it, and of course you can tell the difference when you interact. That we can create those blocks in real time and synchronize them, and with the other users in real time.
Mm. When will you guys launch like mainnet? Is there already a plan for that?
Okay, so we officially, there's no official date. We obviously we working really hard to make that happen. Maybe this year, if we're being optimistic and ambitious, and we'll see.
Okay. There's also some stuff on AI that you have been talking about. I think you published an AI light paper. What makes Linera like? How are you thinking about AI? What makes Linera an ideal sort of blockchain for AI agents or the likes?
Yeah, I mean, so everybody's looking into AI. Obviously, AI is one of the most exciting technology that advanced so brutally, like recently. So the nice thing about Linera for AI is this framework that I was explaining just a minute ago, where we let the clients actually have local replica of the microchains they care about, and give them the opportunity, the possibility to execute blocks and have a trusted local state. That is actually really useful for AI, especially for AI agents. Why? Well, because now we're going to give a microchain to each AI agent, essentially. And these AI agents, we have a demo where they can talk to their own microchain. And the microchain has a local replica. So that is trusted because it's local. And now you can talk to that replica, and you can ask questions, and you can trust the answers because it's on the same machine in the same security environment, right? So you basically and that was the initial design where that's how front ends are supposed to use Linera. They're supposed to talk to the replica of the microchains and ask them questions. They say, hey, I will start a transfer. Can you start a transfer for me? Or hey, what is my new balance? You told me that there was a refresh. The data have been refreshed. So what is the new balance? And all those questions, they use Web2 standards, GraphQL, JSON. There's no more blockchain in there. There's no that we abstracted away blockchain in this dialogue between front ends and microchains locally. And now, if you replace the front end by an AI agent, it just works. You have the AI agent that say, hey, what can I do with my microchain? And we say, okay, well, this is the GraphQL schema. So these are all the APIs you can use. And then the agents, okay, oh, that's cool. Okay. Yeah, well, I'd like to start a transfer. And then we're like, okay, well, this is the API. You need the address. You need this. You need the amount. Okay. Well, okay. So the agent fills the blanks and okay, this is what I want. Sends you the GraphQL query. and you execute it like it was like a command from the front end. And this is all essentially worked out of the box. We didn't have to do anything special about it because we already supported those Web 2 standards that AI agents are completely capable of learning. So that's one aspect that is really cool. I think is once you have a client that has this trusting replica of microchains locally, you can just make them talk to your AI agent or respond to your AI agent. And the agent doesn't need to know the bytes that make transactions in your blockchain or something like that, right? That's the problem with traditional infrastructure, traditional designs, is that you expect the front ends to actually create the transactions, putting together the bytes, and then signing them. And that's way more things to learn from an AI agent.
Because you then also need secure key management for the AI agent, for example.
Well, and the agent would need to learn, oh, I have a wallet. When I need to sign bytes, I need to ask the wallet, So in our case, we tell the agent, just tell us what you want to do, and we'll talk to the wallet for you.
Yeah. But can the agent then also interact with a smart contract that exists on some other microchain or some other chain in the Linera ecosystem then, for example?
Not directly. In the purest Linera design, you wouldn't have access to that. Not that it's private, but the assumption is that maybe you don't need it. It's like you can't. And when you look at traditional Web 2 applications like a social network or like you can't usually take a peek at the accounts of the other users, right? So they would need to explicitly send you a message or make something available to you for you to interact with it. And so based on that idea, that's that kind of in Linera, we make it very easy for you to read your own microchains or some microchains that you explicitly share with other users. But if you want to take a peek at the microchains of other users, then you would need to either you would need to tell your wallet, hey, I want to listen to that thing, so we need to replicate locally first, or that will be eventually doable also using like classical RPC systems. But then you will fall into the usual trade-offs with security and maybe latency as well.
What are some apps that you foresee building on this? Like what kind of use cases?
Yeah, so we apps that work on Linera the best. So we're talking to, there are many, like this is really interesting because like we're basically looking at existing Web3 applications, and every time we're thinking, okay, how can I make that take advantage of Linera? And sometimes the answer is well, it's gonna work, but it's gonna work like usual. And sometimes like okay, it's gonna work and it's gonna be completely like so much more scalable on Linera. So one example, if you want to do sporting bets or perpetual futures, and so now suddenly every user, they have their own chain, they have their kind of own personal casino, so they can make the sports bets locally and say, hey, I bet that this thing is gonna happen, and then an instant later they can make another bet, they maybe cancel the previous one, or and all of those interactions, they happen in the reserved block space of the user in their own microchain. So we can guarantee the users that those interactions are going to always be instant. There's the fees are going to be flat, the delays are going to be guaranteed simply because you are talking to your own microchain. And so that's one thing. And you could have millions of users doing the same thing, and we would be able to scale out the system, the network under the hood, and just make the interaction seamless. So that's one example. It's super. I think it really shows the power of having parallel chains, and especially parallel user chains, to allow users to make their bets in their own thread, in their own reserved block space. Payment system work like this, and in addition, in the payment system, so I talk to my own chain and say, hey, I want to start a transfer, and then the transfer sends a message to the other user's chain, So payments are also very interesting. They are immediately infinitely scalable if you run a payment system on Linera, which was in fact the initial research. So it's not completely surprising. What else? If you want to run a decentralized debate, then you would create a chain. If you want to auction an object, you would create an auction chain just for that object, for instance. So that's one thing also, that can really take advantage of the microchain programming model. Auction systems are peer-to-peer DeFi. So I want to ask you, hey, I want to extend. If I know who to ask, I have like a favorite market maker, and I want to ask them, hey, what is your price for Bitcoin versus USDC today? And they can respond to me, and then we swap directly. And I can talk to them, and it's so potentially there could be also millions of users interacting in a peer-to-peer way and trading things in parallel instead of having everybody talk to the same order book. That's an alternative design also that I found super interesting. And then there are, I can go on and go on. Basically, we are like really revisiting Web3 one app at a time and seeing, how we can help it and maybe scale it better. We also have capabilities that other blockchains don't have behind scalability. Beyond scalability, the ability to query services such as data services or AI services directly from Linera transactions. So we have a partnership with Walrus, the data availability layer of Sui, where we are going to be acting as a data availability layer for them. Sorry, as a data validation layer for them. Meaning that if you are a Sui user, you have a Sui application, and suddenly you have a question about some data that have been uploaded to Walrus. And what you could do, and so what you can't do is directly downloading the data and checking them, because downloading data, if you are a Sui transaction or a transaction in any blockchain out there, Solana, Ethereum, you can't download data from the internet into a transaction. That just doesn't work. However, Linera can do that. The design of Linera actually allows, in my own microchain, I can create a block that has a question and say, hey, I would like you to download data from the internet and apply this function to it and tell me if it works, if the property is true. That transaction may take 5-10 seconds. There's maybe a little bit of non-determinism attached, so maybe the transaction may fail. We don't know. But it's in my own chain, so I can try my luck. I can create the block and see if the transaction goes through. If enough validators agree that the transaction is correct, then it will be certified, and my chain can carry on. If it takes more time, then my chain may be slowed down for a little while. But it's only my chain. Every other user in Linera is fine. And that's really the difference between Linera and a traditional blockchain system where you have the single chain for every user. They would never let you, create a transaction that tries to download stuff from the internet, takes 5 seconds, maybe is not even deterministic in a traditional blockchain.
How many chains will there be on Linera?
Honestly, there's no limit. It's like a user account. And if you don't use it, it just stays in storage. So yeah, we probably have already thousands of them in our testnet, like maybe 10,000. But yeah, it doesn't matter. Like, it's really what matters is the number of active users at a given moment. This is what costs. This is what takes create some load on the servers.
Sounds like one has to rethink the whole concept of it to understand Linera properly.
Well, that's our job to explain. And then at the end of the users, they want something that works. I think this is also one of the lessons of being a software engineer for many years is that you at the end of the day, the users they don't really care if this was very, very simple or very complicated to write the software. And what they want is the performance. They want the reliability. And there are like some stories of I think it happened to many software engineers. You write your prototype in a high level language that was before Rust in any way. you write your software in some very developer friendly language, very high level, but then it becomes a bit slow, and somebody arrives and rewrite it in C++. And then you can complain, oh, C++ is complicated, but at the end of the day, the thing is working very fast, and that's what users want. Well, this dilemma has been solved by Rust, in my view, if you're familiar with the Rust programming language. But in the world of blockchain, what we're proposing is a programming model is much more rich, gives way more power to the developers. It's very different, but also very interesting. And more importantly, at the end, creates really beautiful real-time applications.
That's really, really cool. How much funds have you raised? And are you doing like more token sales or something also where like retail can contribute?
We'll see about that. So we had two rounds. I raised 6 million twice. We are going to have some opportunities, probably pre-TG for retail. It's a bit too early to talk about it though. But yes, we are thinking definitely about on our way to create the token. We're thinking about giving some opportunities for retail investors.
Okay, cool. Well, thanks for sharing. Where can people go to start building on Linera or to kind of join the community?
Yes, the best thing is to find us on Discord or Telegram. You can find all the channels on our website linera.io, and then for the technical material, linera.dev is the best. The reference manual is the best entry point.
Awesome. Thank you, Mathieu. That was really interesting. All the best with the launch. And yeah, any last words you want to share or?
No, thanks for having me. Always a pleasure to explain Linera, and we hope to see everybody on Discord soon.